Of leaky gut?
Leaky gut? Well, Jeff Foxworthy says you take it. I'm just kidding. Leaky gut is when the intestinal lining, so normally has these little brush borders. Let's actually do this a little slower. Inside of the gut, in order to increase the surface area, the surface of this gut has what we call microvilli. And these microvilli, if we actually take this section out and look at the microvilli, these microvilli in essence have little doors or portals through which then foods or proteins, healthy feeding properties can actually enter into the body. And what often happens is, because of food sensitivities, it's almost like every time we eat certain foods, these start to get rubbed off or erased off. Okay? Now this true condition is called celiac disease, right? Where the microvilli are actually being eroded, and that villus erosion is called celiac disease. Now we've talked about that before. But leaky gut then is where these portals become very permeable. They don't require an energy exchange, and the doors just open up and whole proteins start to pass through, and with that then bacteria, and the body starts to become very reactive to undigested proteins. It can be anything from grain glutens to soy to dairy casings, eggs, and fruits, so we start to become very reactive. And these poor people are the ones that when they run a test to evaluate their food sensitivities, they're sensitive to everything, okay? And that's leaky gut. Is that okay? Does that make sense? Okay. Anybody have a question to that point? Please.
Where does CoQ10 come into this description that you've made here?
In the Krebs cycle, great question, Sterling. This mitochondria, in the membrane, there is a cascade where the electron, basically, the oxygen that is binding with the different molecules that actually deliver the electrons to this point, okay? And CoQ10 or CoQ10, ubiquinone, is one of the steps in this cascade that catches the electrons to be able to convert it then to ATP. Because that electron gives off its energy and is then rebound to something else. It's actually giving off energy that then produces or recharges the ATP. And ubiquinone or CoQ10 is part of that Krebs cycle. Okay? That makes sense? So it's in the mitochondria. So if you think about that actually is a great question you're actually asking. I was from the South, I just said axing. Metabolically active organs in the body, if you think about those that are constantly moving, try to think of an organ that is constantly, right? Constantly moving. That heart muscle, imagine the concentrations of mitochondria in that heart muscle. Okay? And all it's asking for us to do is to feed it so that those arteries that come around, those coronary arteries, can do their best job and give the blood supply back to feeding those mitochondrial organelles with oxygen and the sugar that they need to be able to burn that off. Okay? So when you look at heart health, CoQ10 can be one of those supplements that we really want to use to feed the heart, right? Mm-hmm. It's another very metabolically active organ in the body. Mm-hmm. What produces urine? Kidneys, okay? Kidneys. There's actually a study, a research study. You can all look this one up online. It's pretty fascinating. They took a group of people who were on kidney dialysis. They gave them 100 milligrams CoQ10 twice a day, BID, okay? And in that study, they were actually able, after a 2-week period, to be able to take many of the people that they had on dialysis off because their kidneys started to kick back in. Very essential for metabolically active organs to be able to function optimally, CoQ10. Okay? But why would CoQ10 be low? Why would these mitochondria be starving? Why would they be suffering? A big part of that comes back to another very, very large metabolic organ in the body. Let's go ahead and get us a model up here again.
They're going to be lungs or liver.
Yep, that's right. Okay. So let's just get this model up here for a minute to kind of get an idea, to orient ourselves again. On the right side of the body, in the front is just under the ribs, is this large metabolic organ we call the liver, right? So this is the liver. Along with the liver is this biliary tree, which then collects into a phenomenal organ that so many people don't need, right? You don't need this organ, right? Especially if you're an expert at being able to remove this little organ that everybody doesn't need, right? What is that?
Gallbladder.
Gallbladder, okay? There's little Mr. GB who's so expendable, and of course I'm being facetious in that, right? So the gallbladder's there, and the gallbladder actually empties into a duct that comes from another friend over here that has the ability then to help us to digest, and those two then join into a tube called the common bile duct, empty into the second part of the duodenum. What's this guy called? Yep, this is the pancreas. Okay? There's the pancreas. Then, tucked right up against these guys in the back, are these two wonders. Genius. Okay? Paired, they just look like those beans that you throw in the pot, don't they? What are these guys? Kidneys. Okay? Look at how integral this is. I mean, this whole system is right here. And right above this system is this guy, and this big guy. Okay? Yeah. Vitals. Okay? This literally is vital to every system function. And what is it vital for? The preservation of the big guy upstairs. 70% fat, the brain. Okay? So when we look at all of these processes, all of these organs are working together to preserve the man upstairs. Okay? To be able to help him be able to keep us alive. The frontal lobes, this area of the brain, are what just separate us from everything else. It's the ability to be human, to express ourselves, to be able to have relationships and interactions, to be able to have compassion and care about somebody, to be able to want to serve, to be able to want to go home at night, even after you've been in a fight, right? It's the beauty of being human. And be awakened in the middle of the night to a screaming kid. Again? Yeah.